Yes,
Or even
ma'am.
mine?
Because sometimes your
Okay.
voice was also
So
echoing,
I
but
think,
now it is not echoing.
okay. So I think you can start. You, yes. All the best. Start teaching.
So, anybody has a
So,
guess
anybody has a guess
which chapter we are going to
which
start?
chapter we are going to start?
Urjita, your voice is echoing.
Um, Wait.
I think Urjita is using two devices. She needs to switch off the mute one thing. I think she's using one to present. So other device she can mute. Otherwise, this will keep echoing.
Ma'am, actually, I had the same device and one was already mute, but I have like exited
Okay.
right
Yeah.
now.
Now you can. Now it's not.
So it's, am I
Yes.
audible now properly? So any guess which chapter are we going to start?
Technology.
Anybody? Yes, right, correct. So I will be presenting my screen and showing you a PPT, and then we'll be having a quiz also. Are you all able to see my screen?
Yes.
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 So what does work means? Anybody of you can read and say if you want. Anybody volunteering? No? Work is
Work.
said to be done.
May I?
Okay, you can say.
Work
Work,
is
work is said to be done when force applied on an object causes that object to move through a distance in the direction of force.
Okay, so there's particular work that we do in a day. So it is actually a little different. It's a little different from the daily work that we do. We study, so that can be counted as a work because though a lot of mental work is involved in it, but you don't apply force for it and no object is moving in a direction of the force. So you can see some examples over here, I think, in the pictures that can be said as work when it's done. So which the arrows are pointing, and which these two pictures where the arrow is not pointing is when the work is not said to be done. Over here you can see a man using a pulley. So when he's using a pulley, he's applying force, he's pulling it. So that's why the object over here is moving upwards in the direction of the force. Same over here on a plane, the man is pushing the block and the block moves in the direction of the force. Over here, you can see a seesaw. So over here, when the person applies more force downwards, the seesaw tilts towards the downwards direction. So measurement of work. Anybody reading?
Shall I?
Yes.
Two main factors to determine the amount of work done: the force applied and the distance through which the objects move in the direction of force. Work is equal
So
to
as
force into distance, and 1 joule is equal to 1 Newton into 1 meter is equal to 1 Newton meter.
yes, very good. So, two main factors. So, as we saw in the definition, we actually saw the word force, and we saw the force in which the movement of the object in the direction of the force. The same two factors are very important when we try to measure how much work we have done. So, the force applied on the object. So how much force are you applying first of all, and how much distance has it moved through that force? So that will determine your work done. So work is equals to force into distance. In short, to calculate how much work is done. So 1 joule. So joule is the SI unit of work, and is equals to 1 Newton. Newton is the SI unit for force that you apply, and into 1 meter, that is the distance the object travels, is equals to 1 Newton meter. And 1 Newton meter is another name for joule, so that is also count as the SI for work done. So you can see an object over here. This object, when the force is applied in this direction, so from this to this, so in the same direction it is traveling to a particular distance. So I will like Simran to take over right now. Simran.
Hello. So now we can do numericals of work. So find the work done if a force of 1000 Newton is applied on a load and the load moves through a distance of 50 centimeters. Can anyone tell me what is the formula of force of for okay. Can anyone tell me the formula for work?
Force into distance.
Yeah. So from this question, what data can you collect?
The force applied is 1000
Distance
Newton.
and force. Force applied 100 Newton and the distance is 50 centimeters.
Yeah. Okay. So where did that change? Hello, Urjita. Urjita. Change.
Hello. Your voice.
Yeah.
Yes.
So
Your
force
voice
is
is not
given.
clear, Simran.
Distance. It's not clear. Hello. Can you hear me?
It is clear.
Okay.
Yes, we
Okay,
can
ma'am.
hear you.
So data is given. Force equals to 1000
It
Newton.
might be problem for my side.
Distance equals to 50 centimeter and work equals to question mark. So formula is work equals to force into distance. Can anyone find out the answer if you wish to? Okay, the distance is given in centimeter, and obviously distance is always in meter. So we convert 50 centimeter into into meter. So 1 meter equals to 100 centimeter. So 50 centimeter equals to 0.5 meter. And can anyone like to calculate the force? Oh, sorry, the work.
2500.
Uh, let's check the
2500
answer.
joule.
Answer 500 joules. 1000 into 0.5 is 500. Okay. Next numerical. If the work done in pushing a trolley by applying force of 750 Newton is 1277 joule, calculate the distance moved by the trolley. What is the data given? Can anyone?
Force is 750 and work
And
done is
and
1277 joule.
yeah. So can anyone tell me the formula for distance now?
Work upon force.
Work
So
done
would you
upon
like to calculate that, or would you like to calculate that? The distance traveled?
1.70 meter.
Correct. Good. Okay. The next numerical. This one you have to solve, okay? Not try to solve. Collect the data and then collect the data, apply the formula and solve it and tell me the answer. Rohan pushed the toy car and it moved a distance of 4 meters. If the work done by him is 1200 joule, how much force did he apply through the push? So you have to calculate this. Okay, tell me.
Can you tell the answer?
300 Newton.
300.
Yeah, correct.
300 Newton.
Correct. Urjita, change. Urjita,
So, right, not share the screen now.
did you all get till here whatever we taught? Like,
Yes.
did you? Okay, thanks.
Yes.
Yes.
Now Vedant will continue ahead, okay?
So now that you know what work is, we will be understanding what is the energy behind this work. So energy is basically of two types, kinetic energy and potential energy. But before
Vedant,
going into that,
if you can put
yes,
your
ma'am.
screen properly because it's vertical and we're not able to see you. It's tilted. If you can do that, please.
Is it okay? Ma'am, is it okay now?
No, it's still tilted.
Ma'am, now is it okay?
Yes, now it's okay. Yes, yes, Vedant.
Okay, so now that you all know what work is, now we will understand what is this energy behind the work. So work and energy are closely related. We can prove that, like if we take a stone and throw it on a glass pane, at that time the stone will be traveling with some energy towards the glass pane, and at that time the glass will break. So this is the energy which was converted from what it was when the stone was ready to move, and then when it was traveling. So this is how we can say that work and energy are closely related. Now,
Ma'am,
energy we all know is defined as capacity or ability to do the work.
students were not able to
So it
join.
is the ability or the capacity to
No,
do the work.
8th F में उसका
So
था,
whenever
8th F,
work is
yes.
done, there is a
They
transfer
are
of
using the
energy.
link
So
मैंने बोला
from
you.
one type of
I
energy
don't
to
know,
another
same
type of
link वो
energy
share
is the
किया. I did
transfer
it
of
twice, but they're not able.
energy. So there are two forms of energy, that is kinetic energy and potential energy. Kinetic energy depends
And
on
it's
the state
already
of motion,
10:20. They
and
missed out their
potential
class.
energy depends upon the shape, state, or position.
10:20 हो गया
So,
already, and
so
हाँ,
basically,
they
the
missed.
energy that an
Actually, they
object
were
has
not
due to
able to
its
join
state,
that
shape, or
link.
position is potential energy, and the energy that an object has due to its state of motion is called the kinetic energy. So this is what is potential energy and kinetic energy.
हाँ, मैंने उनको बोला try
Now,
using your email ID, Billabong email ID and all. मैंने
kinetic
क्योंकि
energy
I am also
can
here
have
in middle of
examples of kinetic energy can have examples of like running kids, steering cars. So all of these are examples of kinetic energy. So whenever some object is moving through a distance, that is always kinetic energy. And potential energy is depending upon the shape, state, or motion. So if the thing is compressed, or it is bent, or it is pulled, or if it is on a height, then these all are the factors which tell that the energy is potential energy. Now, when we are talking about energy, so kinetic energy and potential energy can together be called as mechanical energy. And the mechanical energy is what which is using flying rockets or sites. So that is where mechanical energy together, kinetic and potential, is used together. So this is what is the meaning of mechanical energy. So kinetic energy is, as I told you, depends upon mass and speed. So if the object is heavy or if it is speeding, then the kinetic energy is more. So so on that, the formula of kinetic energy is half mv square. So that means that kinetic energy is proportional to twice the speed. So that is why if you are told that what is the kinetic energy when it is increased twice, so it will be actually becoming 4 because the speed gets doubled up over here if kinetic energy is increased twice. So that is why if it is told to calculate the kinetic energy twice, then we have to multiply it by 4. If it is told by 3, then we have to do it by 9. And that is why with with the boost of little kinetic energy, the speed increases more, and that is why it is dangerous to do overspeeding on roads and highways. Now, potential energy actually is of two types: gravitational potential energy and elastic potential energy. Gravitational potential energy, as the name tells, it is depending on how high the object is. So this means that the object which is there is in a potential to fall down, but it is not that always it falls down, but it is in a potential to fall down. So if you take example of a water tank kept, so when that will fall down, at that time it will be released from potential energy to kinetic energy, but the potential energy type is gravitational potential energy. And elastic potential energy depends upon when the object is stretched, compressed, or bent. So that is what is the meaning of elastic potential energy. So examples would be stretched slingshot, bow and arrow, stretched one. Now why stretched? Because it is in a potential when stretched to get changed into kinetic energy. So that is what is the meaning of elastic potential energy. And gravitational potential energy, when we are talking about, so it too has a formula, and that is mgh, m into g into h. So over here, the gravity is always taken to be as 9.8 meter per second square. But for our convenience of calculations, we take it 10 meter per second square. So now this all theory part is clear. We can proceed to do numericals. So if kinetic energy if the question says that we have to get kinetic energy, then the formula is half mv square. So always we have to write in the data m and v square also. So this question says what is the kinetic energy of a 45 kilogram rickshaw moving at a 10 meter per second speed. So as the formula of kinetic energy is half mv square. So this would become 1 upon 2 into m is 45 kilograms and v square. So it is twice. So we won't write 10 one time. It will become 10 into 10. So this would become like this. So it will become 2250 joules, and we can convert it into kilojoules by taking it 2.25 kilojoules. So 1 10 100, so it will become 2.25 kilojoules. Both answers are correct, but then it's better to write in kilojoules because the answer gets reduced a little bit. Now the second question is again about kinetic energy only. So let's have a look at that also. So the kinetic energy of a moving car is calculated to be 12,50,000 joules, and the car has a mass of 1,000 kilograms. With what speed is it moving? So this time it is they are asking about the speed. So how will we calculate the speed? Now, kinetic energy is half mv square. So this v square will come on the left hand side, and kinetic energy will come on this side, and that is why this 1 upon 2 would become 2 kinetic energy upon m. So that would become 2 into kinetic energy 12,50,000 joules upon mass being 1,000. So this would become 2 into 1250. So this would become 2500. It would just become 2500. But then we still have something left, and that is v square. We need to convert it only into v. So to do that, if it is square, so what will happen? It would become a root of 2500. And for getting a root, we can just use this method. So it would become 50 meter per second. So this is about all the numericals of kinetic energy. Let's have a look at the numericals of potential energy.
Can you just repeat the second sum, like just the
This
explanation
one?
part?
This
This
one?
sum, yeah.
Okay. Yeah, I'll do that. So kinetic energy is 12,50,000 joules and mass is 1,000 kilograms. So kinetic energy's formula, we know it is half mv square. So what will happen is that the formula will change into v square coming on left hand side, because we have to find v square, and it will become 2. This 1 upon 2 will change into 2, because what will happen is the whole thing will go there and then this will come. So it will become 2 ke upon n. Okay, the kinetic energy will come over here and m will come over there. If we have to find the mass, the same thing will be. The kinetic energy will be above and this will be, speed will be below. And then we have to just add in the numbers and then come to over here. And then as this is v square, we need to convert it only into v. So that is why we take a root over here. 255, 2 into 5 into 5, that would be 50, and that is the answer. You can also cross check this thing by using the reverse formula. Now we know the formula is half mv squared. So you can just, the mass, it is 1,000 and it is 50. So we can just do like this. Okay, and this would become, and then yeah. So see. So the answer by doing the reverse method we also got. So this is how we do this. So shall I go to the next question?
Yes.
Okay. So next question is about potential energy this time. So I'll just change the data over here. So when it is potential energy, the formula is m into g into h. So that is why we will write PEMGH in the data. So an owl has a mass of 3 kilograms. It dives to catch mouse losing 900 joules. So we have to write it over here. And then, yeah, how high was the bird to begin with? Now, gravity will not be given because we know that it is 10 meter per second. Okay. We know that it is 10 meter per second. So that is why gravity would be 10 meter per second. We have to write that on our own. That won't be given. So potential energy would be m into g into h, which so we don't have to find potential energy. It is given to us. So we will take height, and then potential energy will come over here, and m into g will come below over here, and then potential energy is 900 joules, and mass is 3 kilograms, and gravity is 10. So 0 0 cancel, and it will become like this, and it will become 30 meters. Okay. Now, I'll just tell you one small thing about these formulas. Okay, now the first formula was about work. Work equals to force into distance. So, distance will be work upon force, and work, well, we know. So, yeah, force would be work upon distance. And then this always would be like this only. Potential energy would be mgh. When we have to find m, it would be pe upon m into h. Oh, sorry. Yeah, g into h. And when you have to find h, it would be pe upon g into m. And for kinetic energy, it would be yeah. So kinetic energy would be half mv squared. So when we have to find the v square, we know what is the formula. 2 ke upon m. So this is just a small formula and it is telling for all. So I think, yeah. So whoever is next can proceed. I guess you can take over. I'll just keep this on if you for some time.
Okay, so now we are going to see transformation of energy. So I will again present the screen. Just give me a second.
It's already 10:30. First period is over. Anything which is it a bulk thing which is remaining now, Urjita?
No, ma'am, I think it's a really very small one.
Okay, try to do it quickly so that
But it's
because
equally okay, ma'am. I'll do it. Yeah, so and get created, changed or transformed into another. So energy is something which is not created, and it's something that already exists, and it can't be altered in any form, but only it can be transferred from one type of energy to another type of energy. So can anyone guess where the energy for to run a car come from? Anybody?
The atmosphere.
Okay, so the sunlight gives the solar energy to the plants, and the process of photosynthesis takes place, and the energy in them is stored as a chemical energy. After the plants store the chemical energy, and we eat the plants, all the vegetarians eat the plants, all the even non-vegetarians over here will also add some amount of plant diet in their plant in the diet, and those plants when eaten by humans and animals get stored in them and as a muscular energy. So after their death, they are buried inside the ground and they form fossil fuels. And in fossil fuels, the energy is stored as chemical energy. After that, fossil fuels is sent into the the fossil is then sent to the factories to generate, you know, and to transform it into gasoline, etc. So when those are filled into the vehicles, these fossil fuels are then burned to release heat energy. That heat energy in the car engine or in any vehicle's engine is converted into mechanical energy, and that's how your car moves. Power, stations generate electricity with the help of hydroelectricity. So the water is stored at a height. So when it's on a height, it contains potential energy in it. And when it is let flow down, the potential energy converts into kinetic energy. The kinetic energy of the running water turns the turbine, and the turning turbine uses the mechanical energy. Then that mechanical energy is then sent into the generator to create electrical energy, and that electrical energy is then transported into a house, and we can then use all the electricity that we use light, etc. So
Okay,
Simran, please take over.
I think the time is already up. It's already 10:37, and they will be joining the other class soon. So I think we can end here. Y'all were amazing. I think the kids also enjoyed. Kids, any student would want to say something, you can. If you have followed or what are your queries, we can end up with that session. Yes?
I just wanted to ask something. While writing the formula for distance, why did Vedant sir use S for writing the distance?
Because for distance,
Yeah.
S is used as a symbol
S is a symbol of distance.
for distance.
Okay, anything else? Anything else, students? So I think it was an amazing session. Thank you so much, Urjita, Simran, and Vedant.
Thank you, ma'am.
And thank you,
Thank you,
ma'am.
ma'am.
Thank you, everyone. Thank you.
I hope you all enjoyed.
Yes. Bye. Thank you.
Yeah, thank you. Bye.
Thank you. Bye.
Bye. Thank you. Bye.
Thank you. Bye.
Thank you. Bye.
Bye.
Bye.